At the point when we discuss the universe, we're looking at everything: Earth, the Sun, the nearby planet group system, the wide range of various worlds, and all the other things we haven't as yet even seen. As a matter of fact, it even incorporates things we can't see on the grounds that the light from them hasn't had sufficient opportunity to contact us yet. It even incorporates things we won't ever see, regardless of how long we stand by, on the grounds that the universe is growing quicker than the light from them is going towards us. So it won't simply ever contact us. That leaves us with a significant gap in how we might interpret the universe. While trying to make quick work of this, the James Webb Space Telescope has said something regarding what is going on interestingly. Be that as it may, it didn't address the secret. James Webb really thickened it, as a matter of fact. As the head telescope looks into the far-off past, it uncovers secrets that were already past our insight. One of these amazing new disclosures even broke our key grasping about the universe and uncovers that we might be totally off base about the size of the universe. Space experts say that we didn't anticipate seeing something like this in the Webb picture. The principal universes developed uniquely in contrast to we expected, and we don't have the foggiest idea why. Their old forecasts were off base. Go along with us as we dive profound into how James Webb just overturned how we might interpret the size of the universe. Can we just look at things objectively? Space is large. You, in all likelihood, will have a hard time believing how immensely, tremendously, stunningly large it is. To give you some viewpoint, we should start by thinking about neighborhood space. Expect that the distance among Earth and the Sun, known as one cosmic unit, is 1 centimeter rather than its real 93 million miles. In all of mankind's set of experiences, we have actually voyaged a subtly little part of that 1 centimeter. You can imagine a scale model nearby planet group in your room, your area, and your town. On that scale, Jupiter would be 5 centimeters from the Sun. Continue to move out, share with the right, and envision the relative distances. Saturn would be 10 centimeters from the Sun, Uranus 19 centimeters from the Sun, and Neptune 30 centimeters from the Sun. Minimal old Pluto would regularly be around 40 centimeters from the Sun on this scale. Nonetheless, the actual breadth of the planetary group is far bigger than that. The external edge of the Oort cloud, the huge shell of maybe 1 trillion comets, would lie 10 football fields away. What's more, we have hitherto voyaged a little, practically imperceptible part of that unique 1 centimeter. What's more, that is only our planetary group. The closest star, Proxima Centauri, is multiple times farther away than the external shell of the Oort cloud. The gigantic hole between even the closest stars would be stunningly enormous. The real distance to Proxima Centauri is 4.2 light-years, implying that light, the quickest thing there is, requires 4.2 years to make a trip from that star to our eyes. We can take quantum jumps up in general scale as well. The smoothway universe is one of somewhere around 100 billion systems in the universe. The distance across of the smoothway's splendid plate, which we are in, is something like 100,000 light-years. We are somewhat more than 26,000 light-years out from the world place. The most far-off photons from our own universe have been making a trip to us for 33% of the length of mankind's set of experiences. Furthermore, similar to settling dolls, we can follow grandiose designs out to increasingly large scopes. Our nearby gathering of systems, as Edwin Hubble named it, thinking back to the 1930s, contains no less than 55 universes in a circle crossing around 10 million light-years. Neighborhood bunch individuals incorporate our close-by companions, the Andromeda cosmic system, and the Triangulum world. Incalculable little gatherings of systems are considerably farther away. Furthermore, assuming that we travel about 55 million light-years, we get to the focal point of the biggest bunch of universes in our grandiose space, the Virgo group. This gathering incorporates around 1,300 cosmic systems, everything being equal. Be that as it may, bigger and more enormous gatherings of worlds lie undeniably more far off from us, almost endless quantities of them. At the point when we get up to the biggest inestimable designs known, we can discuss superclusters and walls of universe groups. Models incorporate Laniakea, which we have a place with, a construction that extends exactly 500 million light-years across. What's more, there are many instances of other enormous designs. So how huge is the universe? It's around 93 billion light-years. The 93 billion years is only the perceptible universe, the universe which we can at present see. The recognizable universe is possible only one part of the universe, and past it, there is logical much more space loaded up with stars and worlds. The motivation behind why there is a recognizable universe is that the universe has not existed for an endless measure of time. Rather, the universe started in the huge explosion of 13.8 a long time back. A limited age for the universe implies that items past a specific point called the vast skyline are essentially excessively far away for their light to have arrived at our eyes. All that we can at present find in the universe is essential for our astronomical air pocket called the detectable universe. Be that as it may, what might be said about the whole universe? How might we our familiar parts that are up until this point away that we have not even seen them yet? That is where things get fascinating. By utilizing the Bayesian model averaging, researchers assessed that the universe is somewhere multiple times bigger than the detectable universe, or if nothing else 7 trillion light-years in breadth. Most importantly, the apparent universe is staggeringly huge, and the whole universe is genuinely gigantic to be sure. The whole universe could be limitlessly huge subsequently. While we can make gauges regarding the size of the universe, researchers can't put a number on it. Researchers presently expect we can draw nearer to the response with the appearance of James Webb. Only a couple of days prior, the Webb telescope commended its second commemoration as the world's biggest and most remarkable space observatory. Not at all like its ancestor, the Hubble Space Telescope, James Webb has some expertise in distinguishing infrared light. This permits it to look through the grandiose residue and gas that dark apparent light, furnishing scientists with remarkable perspectives on far-off worlds, nebulae, and even exoplanets. The lucidity and detail of Webb's pictures have dazed the two researchers and the overall population the same with its momentous goal and responsiveness. James Webb has permitted stargazers to concentrate on the arrangement of stars and worlds with unrivaled precision. By catching infrared light, it has disentangled secrets that were beforehand blocked off, revealing insight into the beginning phases of the universe's advancement. In any case, it required a surprisingly lengthy investment for the primary light discharged by a gathering of old systems to arrive at the James Webb Space Telescope. Specialists have determined that the photons were on the way for in excess of 13 billion years, practically the whole history of the universe, before they arrived at the circling observatory. The outcomes are deductively emotional and have uncovered that the universe was at that point profound into the course of star development just a brief time frame after its enormous detonation birth. Albeit the photos themselves are barely staggering for all intents and purposes, simply a modest bunch of smirsish, 2 or 3 gleaming circles, and a picture depicted as a sparkling canine bone. By and by, the universe of stargazing has been stunned. Among the articles trapped in the telescope's monster reflect is one that ends up being the most seasoned known system known to man, the mundanely named J0521 plus 1024. It shows up as it did and only a brief time after the enormous detonation, well before the making of our own planet. It likewise ends up being little contrasted in our own system, yet it was obviously making new stars at a rate tantamount to the smooth way. This trick is shared by a few other old cosmic systems captured by the James Webb Telescope. These previews of the baby universe show that the main stars and cosmic systems had previously framed and were developing a whole lot sooner than most researchers had anticipated. As teacher Brent Robertson, an astrophysicist at the College of California, St. Nick Cruz, said, "These systems are incredibly youthful, yet they have previously become hotbeds for star arrangement. It's astounding." This energy was shared by Kevin Hanline, a cosmologist at the College of Arizona, Tucson. He said, "We have noticed the earliest worlds in the universe, and it has been exciting. It has opened a completely new section throughout the entire existence of cosmology. It is letting us know the universe was dynamic all along." Be that as it may, James Webb's amazing pictures of splendid stars are not by any means the only shocking outcomes. One universe, a practically muddled smear of light named S23316, is causing genuine energy among cosmologists and astrophysicists. It is accounted for to be a stunning 35 billion light-years away. Right away, it might appear to be hard to make sense of how the distance between our smoothway and S23316 has developed to 35 billion light-years, given the universe has just been extending for 13.8 billion years. How might it be that the size of the universe is greater than its age? We should figure it out. We as a whole realize that the development of void space isn't compelled by any means by Albert Einstein's basic speed of light speed limit. Notwithstanding, with regards to objects in a consistently growing universe, the idea of distance turns into a piece dim. So we really want to investigate what we truly mean by distance. In the first place, it's critical to understand that we can't gauge enormous distances straightforwardly, basically not external our nearby planet group. For universes, redshift is the main intermediary we have, and in truth, it just really lets us know how long the world's light has been going through growing space. For example, a universe at a redshift of 5 methods, its frequencies are multiple times their unique worth, and that implies the light has been going for 12.6 billion years. This is known as the light travel time or the think back time, as we are seeing the universe as it was 12.6 quite a while back. Naturally, you would accept that this specific universe is 12.6 billion light-years away. Be that as it may, actually, the cosmic system is a lot further away. In the wake of producing the light that we got, S23316 and our own smooth way have been driven further separated because of the extension of room. The genuine distance of our redshift 5 cosmic system, frequently called the comoving distance, is as of now just about 26 billion light-years. The specific worth really relies on how the universe has been growing through time, which we don't be aware exhaustively. One way or the other, a far-off cosmic system is in every case further away than its light travel time would propose. Shockingly, in spite of being 26 billion light-years far off, S23316 shows up as a somewhat expanded object overhead, with a specific, though little, precise size. That is on the grounds that its apparent precise size was set at the time the world's light was radiated 12.6 quite a while back. In those days it was a lot nearer to our smooth way. For a redshift of 5, it produced the light when it was 4.3 billion light-years from our world. This is all there is to it precise size distance. Since the development of room continually moved the goal line back, it in any case required 12.6 billion years for the light to contact us. In the event that this isn't sufficiently confounding, there's likewise a radiance distance, which lets you know how faint the universe seems as a result of the extension of room, which diminishes both the energy and the appearance pace of photons. Our far-off cosmic system looks much fainter than you would expect for its genuine comoving distance of 26 billion light-years. In a non-growing universe, it would possibly be this weak on the off chance that it were situated at an astounding 155 billion light-years. Getting back to the as-of-late found universe S23316, the light has been going from this cosmic system for 13.5 billion years. In the event that you could set out a ruler today, you'd gauge its comoving distance to be around 35 billion light-years. Since the universe was a lot more modest when the system radiated its light, its rakish size distance is 2 billion light-years. At long last, the extension of the universe diminishing its splendor implies its radiance distance is 65 billion light-years, giving it an unbelievably low surface brilliance. It ought to be clear now why it hadn't been seen until JWST went along, and its revelation is a great accolade for the telescope's light get-together power. Due to the limited speed of light, we see far-off objects as they were the point at which the light was radiated sometime in the past, not as they are currently. To many individuals, this might appear to be an irritation. Space experts will always be unable to realize what far-off systems resemble at this moment. In any case, to cosmologists, it's a brilliant endowment of nature. Because of the think-back time, they can concentrate on the early young people of the universe. You should simply look exceptionally far away into space, and you're consequently looking far back in time. Subsequently, the full 13.8 billion-year history of the universe becomes available to logical request. In any case, note that James Webb is a generally useful observatory. In this way, while zeroing in on far-off universes and star development, its strong, sharp eyes additionally see subtleties in planetary group objects past the scope of ordinary telescopes. For instance, Uranus seems glorious, circumnavigated by gleaming rings and a sprinkling of moons in another picture caught by James Webb. While past pictures of the planet taken in noticeable light by NASA's Explorer 2 test showed it as a consistently blue circle, Webb's infrared view catches its dynamic nature. It even uncovers more detail than the observatory's last picture of Uranus delivered in April. Visible in the new picture are storms, rings, moons, and a glimmering polar ice cap. Uranus is one of a kind among the planets for circling on its side, with a hub slant of around 98 degrees. It has the most outrageous seasons in our planetary group. At the point when one Uranian post is pointing toward the sun, the other is covered in a cool, dim 21 drawn-out winter. Right now, the planet is moving toward a solstice in 2028. The polar cap displayed on the right half of Uranus in Webb's photograph will point toward the sun head-on. Cosmologists will watch to see what information they can acquire from this great perspective on the post. The splendid picture likewise catches the tricky Zeta ring, the deepest diffused ring all over the world. Noticing the rings could illuminate future missions to Uranus. As NASA composed via online entertainment, people need to send a rocket to visit Uranus very close. It's important to comprehend how to explore garbage from its rings. 9 of Uranus' 27 moons should be visible encompassing the planet in the new picture, sparkling like pearls. Individual cosmologists found the ice Goliaths,